Now we get to move to some of the users of CMIP. So first of all, I'd like to invite Leandro Diaz from Argentina, but on behalf of the core projects, or lighthouse activity rather, on explaining and predicting Earth system change, to talk to us about that. Thank you.
Well, thank you. Good morning. Well, first of all, I want to thanks to the organizers for inviting me to give this talk. And as Helen said, I will be here representing the EPESC Lighthouse activity. So just to introduce which is EPESC, as you know, in the last years, we have the 3 warmest years on record. And associated with that, we have so many unprecedented extremes that give us the need to understand which are the drivers of these changes, especially the large-scale changes that we are observing. So this EPESC activity has as the main objective to integrate capabilities for quantitative observation, explanation, early warning, and prediction of Earth system change on global and regional scales, and in annual to decadal or A2D timescales. This activity is chaired by Kirsten Findel and Eric Fischer. And one of the specific priorities is to understand A2D variability and change in the atmosphere and ocean circulation and their influence on hazards. And we need these capabilities and advancing the knowledge and the understanding of this A2D variability and change to inform adaptation and improve their resilience. So this activity is organized in 3 working groups that go from observing and modeling the Earth system to integrate and to the attribution and prediction and projection, and to make hazard assessments, understanding their causes. You could find more information in this paper of Findel and co-authors. So how does our community, the EPESC community, use CMIP simulation? I will say that CMIP data has been a vital resource for developing the capability to explain and predict the Earth system changes in these timescales. Some of the, I will say, 5 points that this CMIP data contributes. One is to assess the model fidelity, so we could know how accurately models represent these high impact events on these timescales. For example, the persistent Sahel droughts on the 90s and 80s. So to have CMIP data allow us to understand if the models could reproduce this kind of high impact events. Also to evaluate the predictability in these timescales. For example, we have the initialized simulation from the Decadal Climate Prediction Project. That is is inside the CMIP last generations. And this allows us to understand how, if the models are able to predict in the near terms this kind of high impact events. Also, we could quantify the uncertainties, especially we could know better the model uncertainties regarding the global and regional changes. We have so many models, as Helen said before, so we could understand better their difference, which is uncertainty. And also to relate the uncertainty related to internal variability. There has been a lot of efforts to increase the ensemble size in the last generation, so we need more of that to better understand the internal variability, the attribution of external forcings, so we could now each time better distinguish the roles of anthropogenic and natural external forcings in the Earth systems, in this case via the detection and attribution simulations that are inside the CMIP, and also to analyze hazards, evaluating how the internal variability and the external forcings influence the frequency and characteristic of these meteorological hazards. So, what is required from CMIP community to enhance the climate research and prediction on A2D scales? Well, I will mention some points that some of them has been discussed in the last year EPESC leader Busan meeting, that now is the report is published last week. And one of them, the first point is we need more frequent updates and extensions of radiative forcing datasets, because the historical forcings are out of date when prediction systems are initialized. This is just an example of a recent paper from Minobe and other co-authors of EPESC that identified as some of the causal factors of the unprecedented extremes of the last years, and one of them is the positive decadal trend in Earth energy imbalance. So we need these updated forcings to understand better how this is working. A second point is we need this updated force in large ensembles to understand why observed trends are outside the range of models. In the left, you could see a figure from the Shaw and co-authors that shows the location of some known model observation discrepancies in historical trends. There are a lot of them that we know, and there are many publications about them. So we need to understand better which are the causes of these discrepancies. At the right, you have, for example, the example of the NAO, that the red line is the observation that are quite outside, like the distribution of the different simulations. So we have a problem there, and we need better tools to address that. Also, the new CMIP, the MIP generation could foster the large ensemble single forcing MIP, which aims to improve our understanding of the forced response of atmospheric circulation to individual forcings and to constraint projections. These are two examples from Garfinkel paper that shows the evaluation of the QBO to external forcings, and the right is one recent paper of Smith and co-authors that showed that we could constrain, based on the understanding of the historical response, the NAO projections. Also, we need that the Global South countries' communities are more involved in the CMIP activities from the beginning, because they are usually big producers of the simulation, but they are important users of them, and so we need to have them from the beginning, so the outputs of this CMIP are more fit to the Global South purpose. And to define the success with respect to CMIP from the perspective of our community, we could achieve success if the new CMIP generations improve our understanding of H2D variability and change in atmospheric and oceanic circulation and their impact on hazards. This also will lay the groundwork from improved prediction on this timescale. That is one of our aims. And also, we will have success if this simulation are more used extensively across all climate regions, particularly in the Global South, are the place where many of these unprecedented extremes are occurring. So we could enhance our comprehension of ongoing hazards in the context of ongoing global warming. So thank you, and if you have some comments on that, we could chat later in the coffee break.
Thank you very much, Leandro. And now I'd like to invite Nobuhito Mori from the Disaster Prevention Research Institute to present his perspective.
Thank you, Elene, and thank you for organizing committee, excluding myself. I'm one of LOC. So thank you very much. My name is Nobu Mori from Kyoto University, and today I'm going to talk about, very briefly talk about collaboration with impact and adaptation users. And I believe many of you are working on a projection, but I'm working on the between. I'm working in between working one and the working group 2 category, so I have some knowledge about collaboration with impact and adaptation users in Japan. Then I just briefly talk about 3 key questions. One is how impact assessment and adaptation community using CMIP data, and the second is what the fraction of the impact and adaptation community needs are met by CMIP data set and analysis, and third is how can we capture user requirement to support CMIP evolution? Actually, third key is very difficult to answer. So first is how impact assessment and adaptation community utilizing CMIP data or CMIP analysis. Actually, impact assessment community and adaptation community are not same. Of course, they are overlapped. So impact assessment community, research community mainly cover more larger spatial area compared with adaptation, and then they are more qualitative, but utilizing more comprehensive information from CMIP data set of a climate community, including different scenarios or uncertainty of the models, and so on. On the other hand, adaptation community tend more focus on local phenomena, and then they require more quantitative information compared with impact assessment people. So they are both impact assessment and adaptation are overlap, but they are not same. Then I'm just briefly talking about Japan case. Masa Watanabe and Michio Kawamiya and myself have been working on the climate change research and implementation in Japan. So in Japan, we have a national assessment report, domestic report, and domestic climate, not domestic, but partially domestic climate data set every 5 years, supported by the CENTAM program, which is one local sponsor of this workshop. And then, of course, we use CMIP data to downscale global information to Japan, and then based on this kind of national report and the national data set, we have been implement or update Japan's climate adaptation plan and adaptation action. So this is one example how we are update river flood managing plan with climate change in Japan. Historically, we used 1 by 100 to 1 by 200 years extreme event, precipitation event for river flood control management based on observation data set. However, since 2021, based on our national climate report and national climate data set, central government started to consider increasing precipitation with 2 degree warmer climate to making river flood control plan. So it's already established in Japan. So this is a kind of real climate adaptation planning in Japan for river flood control. And then second is another case, how in Japan has been suffered by storm surge with extreme tropical cyclone. So in Japan, in Osaka, next to the Kyoto, now we are making new storm surge barrier considering sea level rise and intensified tropical cyclone with 2 degree scenario based on our data set and knowledge. And this is actually real climate adaptation action, not plan. So it's ongoing construction in Osaka now. So based on this kind of communication with adaptation sectors, including stakeholders, we have been accumulated kind of collaboration between climate society and adaptation communities in Japan. So briefly speaking, it is not easy to implement climate information into the existing this is the case of the infrastructure, the existing infrastructure design. First, we have to understand current design protocol for the infrastructure, like previous storm surge barrier gate. Then next step is how we can discuss with stakeholders to implement climate information into the existing design protocol. That was a big challenge for us. So briefly, I'm just explaining how we implemented our climate information into the real climate resilience infrastructure this is a case for the storm surge barrier case. So first step is a choice of the scenario, but basically it depends on the policy, so there was no choice to choose a scenario in this case. Then second was uncertainty of the climate projection. Of course, we need to include some uncertainties of model projection, but we cannot cover all because it's getting expensive, if we pick up, for example, top 1% of the extreme. So we have to carefully, we carefully discuss about how we can include climate projection, including uncertainty, to design critical infrastructure. Then third is a time scale, because infrastructure, in this case, infrastructure will use until the end of this century. So we have to care about time scale of the climate projection. So these three components, scenario, projection-related uncertainty, and time scale of the climate change are very important to implement for designing climate resilience infrastructure. Then lastly, I don't have enough time to explain, but bias of the projection is pretty important for adaptation, because adaptation is quantitative rather than qualitative. So bias with projection is very important. Bias information of the projection is very important. So CMIP may attention showing model bias with future change. Then lastly, in previously, this is our just case study. So we cannot generalize our collaboration results. So I just borrow the results by Skeleton 2017. So there are they categorize user requirement into the two lines. First line is a typology of the user-inspired research, and the second line is the user involvement in production. Then top line means a top-down point of view. So many of you are kind of, scientists, so innovator type can be usually occurred. So advanced of the science is the main motivation of your research. However, if you really want to collaborate with impact assessment or adaptation communities, there are several ways to make your research forward, like a consolidators approach, which is a knowledge exchange and networking with some represented person. And the collaborator is also important, but it's very time consuming. On the other hand, if CMIP or you want to make a user involvement production, there are three categories based on the Skeletons 2017. One is elicitation. So scientists have all the knowledge and the decision. So scientists have privileged decision-making power. So it's very straightforward, but very actually difficult, because you have to cover all the knowledge of the impact assessment and adaptation. And then second choice is representation, and the third choice is participation. Participation sounds good, but it also has some difficulty, because you have to interact all the users and everything. So multiple user interact and equal partnership is participation. So all the this kind of way depends on the size of the country or the community. So I hope CMIP workshop can discuss this kind of collaboration with adaptation and impact assessment communities. And then this is the end of my talk. Thank you very much.
Thank you very much for that insightful talk. And finally, I'd like to invite Anastasia Romanou, who's a coordinating lead author of the 7th Assessment Report, to talk to us about what the needs are from IPCC perspective.
Okay, thank you. Good morning, everyone. Thank you for the invitation. I would like to extend a big thank you to the CMIP organizing committee and, of course, the community who provides the data so that AR7, like the previous assessment reports were possible, AR7 will be also possible. And we have to recognize that CMIP community and the assessment community putting together the assessment report are actually the same people, right? Especially with regards to Working Group 1. Are representatives from modeling centers and analysis groups around the world. So thank you for this incredible work, amazing work, and bringing us here and guaranteeing that we will be on time to deliver what we have been asked for. Helene showed the long history of CMIP and the different assessment reports throughout that time. The modeling community is finding that that's a major way of communicating our results. Communicating our results to stakeholders and policymakers, of course, that's the #1 goal, but also the assessment reports are reference material for the scientific community itself to go back to products that have been vetted and endorsed and verified by the community as a coordinated effort. So it is a very valuable exercise, and we want to safeguard and recognize that we are going together with CMIP in that. Now, we are recognizing that in this latest effort, we are running up against deadlines, very tight deadlines, and seemingly unmovable deadlines. However, there are several model intercomparison projects already underway providing data, and here I am, or going to provide data quite soon. And here I'm providing some examples. There are many more. You can find on the WCRP CMIP website more MIP model intercomparison studies which will provide the data. For example, TIP-MIP will have data on ESGF by June, and also flatten MIP, the CERES MIP as well, and many others. So we encourage the community to look into these data sets early on, even if the actual CMIP 7 runs haven't been started yet or are underway, to provide coordinated analysis of these data sets so that AR7 will have time to look at these papers, these publications on time. And I want to emphasize that the deadlines we have right now for AR7 are that papers have to be published by October 2027. It's a very tight deadline. Okay, so we were asked to address some key questions. Here they are, one by one, with input from many members or lead authors of AR7, but not, of course, all of them. You will have the opportunity to address questions and bring up your questions to CMIP panel during this week. So how does the IPCC use CMIP data and analysis? Of course, AR7 relies on CMIP data. As I said, they have to be published papers. There are new chapters, Chapter 8 on abrupt shifts and tipping points, and Chapter 9 on overshoot scenarios and carbon cycle, which are new chapters, new analysis. They don't have only to rely on CMIP 7 data. They can look at CMIP 6 and CMIP 6 plus data, as I said, TIP-MIP, ERA-MIP, C4-MIP data, and so forth. Many chapters are already organizing side analysis of upcoming data, so we have to be aware of these efforts and coordinate our access to the data through tools that CMIP 7 is providing us. For example, the Rapid Evaluation Framework. tool which is critical, but it has to become more flexible. It has to expand and accommodate requests from lead authors. That's what we would hope. Include the CMIP 5 analysis, already include CMIP 6, but CMIP 5 data as well, and can provide the zero-order diagnostics that we need to assess, to understand in AR7, to understand where how things are moving along in each of our chapters. And of course, it will make a great connection to the Atlas, which has been an invaluable tool from AR6. It has been utilized extensively through all the years and from several communities, of course, stakeholders and policymakers, as well as the public. Chapter scientists already are working to bring the Atlas and REF together. Another question that was posed to us is what fraction of the IPCC needs are met by CMIP and what else is required to support their needs. I would say that up until today we had almost 90% of AR7, excluding observations. CMIP data is almost 90% of where we depend our analysis and assessments on. And of course, the papers that we assess, they depend on. And so we are very heavily dependent on CMIP, and that's why for us it is very important. Now, this cycle seems to be a little bit delayed. We get reassurances that it's not out of the usual, and we should be able to catch the deadlines. It is possibly necessary to have access to previous CMIP data, as I said, especially for analysis of abrupt shifts and tipping points and cascades. And we would like to have access to more information through CMIP on climatic impact drivers, because this will be the big handshake between Working Group 1, Working Group 2 and 3. And we have to remember that CMIP also, it doesn't only serve Working Group 1, it serves Working Group 2 and 3 as well. How do we define success with respect to CMIP from the perspective of a lead author in Working Group 1? For us, CMIP would be very successful, and if CMIP is successful, then we have more chances to be successful of putting together a report, assessment report, is if CMIP can provide new data, new scenarios, alternative points of view, meaning even alternative scenarios, and helps the assessment report community to digest this data. Provokes us to reevaluate where the standards are and brings about novel insights and new understanding. We know what new information AR6 brought on. Still, topics are debated from AR6. So the question is, where is AR7 going to be new? What's going to be new with AR7? We want to highlight new science, for example, carbon cycle interactions. That's why there is a big emphasis on emissions-driven simulations that improves the realism, but also quite possibly broaden the uncertainties. And that's not necessarily a bad thing, because broadening uncertainties means that we understand things better and we understand where the next big questions are. And of course provides argumentation how grounded appraisals by stakeholders and policymakers can be made. Moving on to another question that we were asked, how can we capture AR7 user requirements to support CMIP evolution? We need fast access to data, initial analysis to verify our work. Assessment fast track will be of critical importance, of course, because we might not have all the simulations from CMIP 7, simulations from the modeling groups on time for AR7, and the REF, of course, will be very useful. Needs flexibility and customizability by requests, especially from IPCC authors. That's what we would like to request, and links to the Atlas. And of course, as I said before, speak directly to the CIDs. There are some ESGF issues. We need to simplify possibly the way of uploading and disseminating the data. And again, REF can play the intermediary there with ESGF. And that would possibly alleviate some of the time crunch issues that we have now in groups who are producing and analyzing data. It is very important to highlight the fact that we need to be inclusive both in scenario production and scenario usage. If scenarios are not available now, there are possibly other scenarios which might be available, like the SSP2COM, or scenarios from UNEP, which are scenarios that countries have put together to reach the 2% level, for example. These could be viable scenarios if the CMIP panel can utilize them and endorse them. That would be excellent. We need to be inclusive also. Engaging researchers from the Global South as well for topics such as abrupt shifts, where we have customarily a lot of gaps and missing expertise. What will be new from AR7? What is going to be novel arising? We don't know yet. Maybe we have some ideas, each one for our chapter. Could we diversify our forcing scenarios, as I said? Could we get REF, the Rapid Evaluation Framework, and Atlas working together to not only serve Working Group 1, but also provide data to other efforts like Cordex, etc.? And of course, identify the role that artificial intelligence and digital Earth emulation can play in our research. Final remarks is there are data out there. We should be doing analysis for several of the MIPs that already produce CMIP 6+ results. These need to be assessed too as soon as possible. So yes, there is a time crunch, but also there is a lot of material we can be working on. CIDs are very important to focus on this in AR7. It's important to notify the community and let chapter authors know of upcoming papers that you have. If possibly, use preprint options so that we have access and we know what material is going to come to us. Assessment fast-track might not have all the variables necessary for analysis. Can the CMIP, for example, allow ad hoc requests, especially from IPCC authors? And we should diversify the scenarios we use for forcing. There are many more and perhaps more realistic, and depending on each country's Paris Agreement goals. And thank you very much.
Thank you very much for that, Natasha. Thank you to all the speakers in this session.